So if you haven't already watched the solutions, the questions on KAs, you should do that before you do KBs, because the KBs are very similar, and I'm going to go through them relatively quickly. So it says, what is the pH of a solution containing 225 molar weak base B minus with a KB of 3.8 times 10 to the minus 7? So the KB is very similar to the Ka, except it's for bases and has OH minus in it instead of H3O plus of it in it. But the Kb is products over reactants. So in this case, BH, OH minus, the reactants, excuse me, the products over the reactant, in this case B minus. Notice that the water doesn't count because it's a liquid. So this is the same as the Ka, except it's for the Kb, it has the OH minus in it. Now, in this case, we're given the Kb, so what we need to use is an ice table to figure out the equilibrium concentrations of each of these things. Well, we're given the initial concentration of B minus as 0.225 molar. We're also given that these are initially 0. We're going to lose some amount of product of the reactant, and we're going to gain some amount of the products, which means at equilibrium, we're going to have XBH and XOH minus. But what about the B minus? Well, in this case, it'd be 0.225 minus X, but we can ignore this X, so we don't have to use the quadratic equation if it's less than 5 to 10% of the original value, which in all of the examples in this set, it is. All right, so we don't need to use the quadratic equation. Well, now let's plug in what we know. We know KB, it's given to us, 3.8 times 10 to the minus 7 equals, these are both X times X, just the same as for the Ka, all right? And this one is 0.225, so the B minus, which is what's provided to us, is 0.225. Cross multiply, and we find that X squared is equal to 8.6 times 10 to the minus 8. Take the square root and only take the positive answer. And we find that X is equal to 2.9 times 10 to the minus 4. But what is X in this case? What X is really the concentration of OH minus. So this is the concentration of OH minus. So the POH equals the negative log of the concentration of OH minus, just like the pH is the negative log of the concentration of H3O plus. So in this case, it's the negative log of the 2.9 times 10 to the minus 4, which by the way is way less than 5% of this. All right, and the POH is equal to 3.53. So this is the POH. Now, if this was a Ka question, we'd be done because we'd have the pH. But if we have the POH, we have to do one more step to find the pH, which is that the pH is 14 minus the POH, which is 14 minus the 3.53, and we find that the pH of this solution is 10.47, which is not surprising because we have a base and the pH is above 7. So this is extremely similar to the Ka, which is why I went over it so quickly. So if you haven't seen the Ka one, go over that one first because I go over that one in more detail. But the only difference is we have to add this one additional step in order to convert the POH into a pH at the end. So that's the basic difference between these two problems.